Hello, today we are going to be discussing linear functions. This material and some of these examples come from the OpenStax College Algebra textbook. It's free online. There is a link to it at the bottom of each of these pages. You can see it as we go through the video. So please look there for more information on any of this that you want. This corresponds to section 4.1 in that textbook. Some of this, if you've watched some of my previous videos from previous sections, we've talked about before, but this just kind of puts a lot of it in one place. So we're going to go over this. Determine whether the equation of the curve can be written as a linear function. So remember, for something to be a line, kind of the telltale signs that it's a line is that you have a y and x, or it could just be a y or only an x, with no exponents on the variables, and the variables aren't under a radical, are not in the denominator of a fraction. So it's just like a y to the first and an x to the first. If you see like number 1, it's even written in slope-intercept form, y equals mx plus b, then that's definitely a line. So yes, it can be written as a linear function. So yes, all you're doing is deciding if it can be written as a linear function. Yes. Number 2, this is not a linear function because you have an x squared. You have this square on the x. So this would be no. Okay, number 3. This one, we have a plain x, like an x to the first, and we have a y to the first. So maybe, right? Maybe the fraction's throwing you off. But notice that there are no numbers in the denominator. There's no variable in the denominator. Obviously, there's a number in the denominator, but there's no variable in the denominator. So this would be yes as well. This could be written as a linear function. Okay. The next ones, determine whether each function is increasing or decreasing. The way you know something is increasing or decreasing is based on the slope. So the slope of the line will tell you if it's increasing or decreasing. If you have a positive slope, then the line is increasing. If you have a negative slope, then the line is decreasing. So what we want to do is find the slope for each equation. So for number 4, it's set in function notation. So we know that the slope is in front of the x. So the number in front of the x is a positive 1/2. So for increasing and decreasing, it doesn't matter if it's a fraction, a proper fraction or not. It just matters if it's positive or negative. So since the sign is positive, it's a positive 1/2. And again, we're looking at the sign of the number in front of x, not necessarily the first sign. This will be increasing because it's a positive slope. And for number 5, the slope is in front of the x. In this case, it is the first number, right? So it's -2. Since it's a negative slope, it will be decreasing. And that's all you're looking for. All right, number 6, find the slope of the line using the given information. So in this case, we're given 2 points. So we have a formula to find the slope. So that is y2 minus y1 over x2 minus x1. It doesn't matter which one I call x1 or y1. So I'm going to label the first point as my 1's and the second point as my 2's. So I'm going to have 8 minus 4 over 4 minus a -2. So that's going to end up making it 4 plus 2. So that's going to give me 4 over 6, which can reduce by 2. So 2/3 would be the slope. And that's all we need to do in that one. It just asked us to find the slope. For number 7, we're going to find the slope given the given the graph of the line. So what you want to do here is you want to find 2 points to use. And then you can either use the formula that we just used in number 6, or you can simply count. So remember, geometrically, the slope is the rise over the run. So I'm going to start at this point and go to this point. It looks like the intercepts. So from 0, 5, I'm going to go down. In order to get to this other point, I have to go down 1, 2, 3, 4, 5 units. So -5 since I went down 5. And then I need to go over 1, 2, 3, 4 units. And since it was to the right, it's positive. So here my slope is -5/4. And that looks like it could be right because the slope is decreasing, right? It's going down. So -5/4 seems reasonable. Okay, there is the website for the textbook. Number 8, again, we're trying to find the slope. So you can find 2 points and use the slope formula, or hopefully you have memorized your rules for your horizontal and vertical lines. So a horizontal line always has a slope of 0 every time. Okay. Given each set of information, find a linear equation satisfying the conditions if possible. So for number 9, we haven't done one like this before, but if you remember that this is an x value and this is a y value, then you have 2 ordered pairs. So you could write these as ordered pairs. -5, -4 is one ordered pair, and 5, 2 is another ordered pair. So given that information, we've done that lots of times. So the first thing you want to do is find a slope between the 2 points. So we're going to use the formula. So m equals y2 minus y1 over x2 minus x1. And so I'm just going to call my first ones 1s and my second ones 2s. So that's going to be 2 minus a -4, so that'll end up being 2 plus 4. And then 5 minus a -5, that'll be 5 plus 5, so 6 over 10. Both of those can be divided by 2, so that'll be 3/5. So our slope is 3/5. Now we want to use our slope and one of the points for the point slope form. So I'm going to go ahead and use the positive point and this slope. And now I'm going to do the point slope form. So y minus y1 is equal to m times x minus x1. And so you're going to plug in something for the y1, the m, and the x1. So y1 is 2. And again, I know I labeled my first point as x1 and y1, and you can use that point in this equation. But once you move to this equation, you can use either point you want. So I just randomly chose the 5, 2, and I chose it because they're both positive, but you can choose either one. So we have y minus 2 is equal to m, which is 3/5, times x minus 5. Now our next step, because I want to write it in slope-intercept form, is to distribute the 3/5. So I will have y minus 2 is equal to 3/5 x minus 3/5 times -5. That's going to be -15 over 5, which is -3, so it'll be -3. And then I need to add 2 to both sides to get the y by itself. So I get y equals 3/5 x minus 1. So there is a linear equation in slope-intercept form that satisfies the given conditions or the given information. Okay, number 10. We have an x-intercept at -2, 0 and a y-intercept at 0, -3. So the first thing we want to do is find the slope. So again, we're going to use the slope formula because we have 2 points. If you want to label, you can. So we'll have -3 minus 0 over 0 minus -2, which is going to be plus 2. So negative 3 over 2 is our slope. So now we have the slope, and we are given the y-intercept. Remember that b is the y value of the y-intercept. So since you're given the y-intercept, you can simply jump right to the slope-intercept form of the equation and plug in the m and the b. So y equals, m is negative 3/2, b is negative 3, and so there's your equation. So it's much faster and easier if they give you the y-intercept. All right, number 11. The line is parallel to g of x equals 3x minus 1 and passes through the point 49. So here we need to find a line that is parallel to this line and passes through the point 49. Remember, lines that are parallel have the same slope. So all we're going to do is use this slope and this point and put it in the point slope form, and we'll have our equation. So y minus y1 is equal to m times x minus x1. So y minus 9 is equal to m, which is 3, times x minus 4. So here the key is really just knowing that parallel lines have the same slope, and you need to pick the slope out of that equation. Now we're going to distribute the 3. So we'll have y minus 9 is equal to 3x minus 12. Add 9 to both sides. Again, we're trying to get it in slope-intercept form. Y equals 3x minus 3. And that would be our equation in slope-intercept form. Okay? And the directions don't tell us to put it in slope-intercept form, but that's just kind of the go-to. So if it doesn't tell you, you can write it in slope-intercept form. That's what you should probably do. Number 12, determine whether the lines are parallel, perpendicular, or neither. So parallel lines have the same slope. Okay. Perpendicular lines have opposite reciprocal slopes. And if it's neither of those, then it'll be neither. So the goal here is to find the slope of each equation and then see if they're the same, or if they're opposite reciprocals, or if they're neither. So for this first equation, we're going to start by subtracting the x from both sides. So our goal is to get the y by itself. So we have negative 7y is equal to negative 4x plus 10. Divide by negative 7. So y is equal to 4/7 x minus 10/7. So here the slope is 4/7. Okay, so now we're going to do the same thing for the second one. So we've got subtract the 7x from both sides. So we get 4y is equal to negative 7x plus 1. Divide by 4. So y equals negative 7/4 x plus 1/4. So here the slope is in front of the x. Oops. So here's the slope. And so now we want to compare these two, the two slopes. This one is 4/7, right? 4/7. This one is negative 7/4. Notice the signs are different and they're flipped. That's opposite reciprocals. So these will be perpendicular. So the opposite comes in the sign, and the reciprocal means flipped. The fraction is flipped. So these are perpendicular lines. All right, let's look at number 13. So number 13, we're going to do the same thing. So minus 4x from both sides. So we have 3y is equal to negative 4x plus 12. Divide by 3. So we have y equals negative 4/3 x plus 4. So here the only thing we're looking at is the slope, so that's negative 4/3. And now we want to do the second one, so we're going to divide by -6. So we get y is equal to 8 over 6 will reduce, so -4/3 x minus 1/6. So here the slope is -4/3. And if we compare the two, we see that they are exactly the same. Same sign, same fraction. So these lines will be parallel. All right. Number 14, we want to know if these are parallel, perpendicular, or neither. So we're just going to have to use the slope formula to find the slopes for this. So for the first one, line 1, I will use red. So we're going to have y2 minus y1 over x2 minus x1. So we'll have -1 minus 3 over 4 minus 2. That's going to give us -4 over 2, which is -2. Okay, and so now line 2, we're going to find the slope. So y2 minus y1 over x2 minus x1. So we're going to have 5 minus 3 over 8 minus 6. This is going to be 2 over 2, which is 1. Okay, these slopes are not the same. They're also not opposite reciprocals. They are opposites, but they're not reciprocals. So these lines are neither. They're neither parallel nor perpendicular. All right, number 15, we want to find the x and y intercepts of the equation. So realize that instead of writing h of x, you could write that as a y. So y equals 3x minus 5. Remember that the function notation is just a way to show that it's a function, but the h of x replaces the y. So to find the x and y intercepts, you're going to let one of the variables be 0. So when you're finding the x-intercept, y is going to be 0. So we're going to let y equal 0. So 0 equals 3x minus 5. So we're plugging in 0 for y. And then we're going to solve. So add 5 to both sides. So we get 3x equals 5. Divide by divide by 3. That's what's in front of the x. So x is equal to 5/3. So here our x-intercept is, well, 5/3, 0. X is 5/3 and y is 0. So here's our x-intercept. Now I want to find the y-intercept. So I'm going to have x be 0 for the y-intercept. So y equals 3 times 0 minus 5. That's just 0. So y equals -5. So 0, comma, -5 is our y-intercept. Okay? So something else you should be able to do for this section is to write an equation for the line graph. Remember what you need to write an equation of a line. If you have it in slope-intercept form, you need the slope and you need the y-intercept. If you have those two pieces of information, you can write the equation of the line. So you want to look for that on your graph. So it's really easy to find the y-intercept. That's where it crosses the y-axis. It crosses the y-axis at 0, 1, so that means b is 1. Okay, and then you want to find the slope. You do that by picking 2 points, and you can either use the point, or you can use the slope formula, or you can just count. So remember, rise over run is the slope. So I'm going to go from this point to this point. So if I start on the bottom left, I'm going to have to rise in order to get to the second point. So 1, 2, I'm going to go up 2 units. So since I went up, that's a +2. And then I'm going to have to move over 1, 2, 3 units to the right. To the right is positive. So my slope is 2/3. So using those two pieces of information, I have y equals 2/3 x plus 1. That's the equation of the line. So that's simple enough, right? Look for the y-intercept, where it crosses the y-axis, and then just count from one point to another for your slope. Number 17, so the b, where it crosses the y-axis, is 3. The slope, remember the slope for any horizontal line, is 0. So I'm going to have y equals 0x plus 3. 0 times x is 0, so you don't need to write that part. So that's why you just get y equals 3. That's the equation of the line that's horizontal through 3. All right, number 18. Here, your b, there is no b, right? There is no y-intercept because it's a vertical line. The slope is undefined. For a vertical line, you have to remember that your equation is x equals whatever value it's going through. So this is passing through the x-axis at -3, so your equation is going to be x equals -3. So the last part of this section is sketching a graph given an equation. So I'm going to graph all of these on this axis, on these axes, to show you how to do it. So the first equation is for number 19. We have y equals -2x minus 1. So I'm just replacing the f of x with a y. It means the same thing. So when you're graphing a line, you start by graphing the y-intercept. So here the b is -1, so that's where it crosses the y-axis. So you put your first point there. And then you're going to use your slope to find other points. So remember, your slope is rise over run. Our slope is -2, so that would be like -2 over 1. You only apply the negative to one of the numbers. So you could apply it on the top as a -2 over +1, or you could apply it on the bottom so that it's a 2 over -1. Either of those mean -2, so it's okay either way. So if I apply it the first way, I'm going to go down to right 1. If I apply it in the second way, that means up 2, left 1. But notice, either way, I'm still on the line. Okay, and so then you would just connect these points, and you would have your line. Okay, so graph the y-intercept first, and then use the geometric interpretation of the slope to find other points and connect them. All right, I'm going to erase this one, and then we'll do number 20. So number 20 is let's try to write these down over here so I can see them. Number 20 is y equals 2/3 x minus 3. 21 is x equals -1. 22 is y equals 3x. And 23 is y equals 2. Okay, so now that I have those, I can just scroll up and then keep it here so we can see the graph the whole time. So let's work on number 20. So number 20, I have the -3 is my y-intercept, and then I'm going to use the geometric interpretation of the slope, so they're positive, so it's up 2, right 3, up 2, right 3, and I can keep going. I could have also gone down 2 and left 3, because 2 negatives make a positive. So down 2 and left 3 is also on the line. And so then you're just going to connect those dots, and you will have the line for number 20. So that's number 20. Okay, I'm going to erase that one. Okay, now let's look at number 21. So 21 is x equals -1. Notice there is not a y, it's just x. So remember that this is one of your special cases. If you only have an x, that means it's going through the x-axis at -1. So through the x-axis at -1. So it's going to be this vertical line through -1. So that would be the graph of 21. Okay, now let's erase that one. All right, let's look at number 22. So number 22, we have y equals 3x. We have an x and a y, so this is not one of the special cases. Contrast this with number 23, where we only have a y. There's no x. That will be one of the special cases. That will be a horizontal line. But 22 is not. Here's the key here. If you do not have anything added or subtracted to the end of the equation, you can put a +0. That doesn't affect the equation, and then that shows you what your y-intercept is. So if there's not anything written there, your y-intercept is understood to go through the origin. It's understood to be 0, 0. And then you're going to use the slope. So 3/1, so I could go up 3, right 1. Or I could go down 3, left 1. And if I connect those, whoops, that is horrible, but we're going to pretend that's a straight line, right? If I connect those, I get the straight line that is y equals 3x. Okay, so I really wanted to make sure I showed 22 and 23 because those are two that students sometimes get confused on. Okay, so now number 23. This one only has a y, so this is one of the special cases. It goes through the y-axis at 2. So it goes through the y-axis at 2. So it's going to be the horizontal line right there.